I mean, major topics you can understood that limit. How could you check if some graph is given to you? Then at some particular point, function has a limit or not. Again, same with continuity. If some graph is given to you or some expression is given to you, how do you check the continuity? The basic limit operation, right? You know the limit of sequences. How do you compute the limit of sequences, right? So these are 3 to 4 major questions, right? There will be questions. I mean, there will be short questions from these questions because what we discussed in week 5 to week 8, just limit continuity, differentiability, and logarithmic exponential, right? So you can expect these questions.
Thank you. Actually, there was a question like find the largest value of a such that the function is defined for all real numbers. So, like, how do we find the largest value of a? For the smallest sign, yeah, I know. For the largest, I was looking at
Largest value. Maximum, minima, this concept, I mean, application of derivative is not there in I think so.
No, actually, I got I got this question from TY last year. TY.
Even quiz 2 or enter.
Quiz 2, sem 1 quiz 2.
Okay, but
I was
in our syllabus.
For the small, like we can get to know.
Yeah, I'll give a brief brief thing that how if okay, let's see. But I think that question will be based on parabola only. I mean, expression will be parabola because you guys are just know the maximum and minimum values of parabola only, that at their vertex we can get a maximum or a minimum depending on the upward facing parabola or downward facing.
Yeah, in that question, like we had two equations, and first was a less than 3, and another one was a greater than equal to a, and there we have to find it.
Yeah, so I think if maximum minimum value is there, then it's surely the parabola thing.
In the end, I'll
Because
just send you the question in the chat box, and then like when you'll be able to share your screen.
Yeah, you can share the question. I also get the access. Let's start our class.
Shall we start or?
Yeah, we just start this. I just got the access.
Ma'am, I had a request.
Yes.
Ma'am, like for our today's session, there was clearly mentioned which topic is going to be discussed in the session. And like, can it happen for all the sessions? Because ma'am, it's very hard to to get what is going to be discussed and what not. Like where the theory is going to be discussed and when the doubt sessions are going to happen. So it's like quite messed up. So if it can happen for every subject, then it quite be helpful.
Yeah, we will. We also plan to do that thing, that we will particularly mention which topic is going to be covered in that particular session.
Yes, ma'am. Because ma'am, it will
because
be really
that will
very
be
helpful
for everyone.
Yes,
if
ma'am.
someone is watching on YouTube, he can't understand week 8 what the things are discussed in week 11. Okay, so let's start. So we'll start by differentiability. So you guys are already familiar with continuity and limit. I hope so.
And also mention TS in which topic.
Sorry, what? Okay, so let's start. So you guys are already familiar with the limit and continuity. Okay, but the main concept is limit. If you guys are, if you are able to understand the limit, then continuity is nothing but a limit which has a particular value. That value should be equals to the value of function, right? What do you mean by continuity? So we say a function f is continuous at a point x is equals to x naught if this limit, that limit x going to x naught, f of x, this limit is equals to f of x naught. That means first we want the existence of this limit, and then we want that this limit should attain the value which is equals to the value of function, right? So what does differentiability is? So in theoretical basis, differentiability is nothing but a particular type of limit. What type of limit? So suppose you have a function f, and then we say f is differentiable at x is equals to x naught if this limit, that limit h going to 0, f of x naught plus h minus f of x naught by h, this limit exists, right? So if this limit, this particular limit exists, then we say that f is differentiable at x naught, and whatever value we get after evaluating that limit is known to be the derivative of function at that particular point x. Okay, is this definition is clear? Just differentiability is what? In theoretical basis, differentiability is nothing but a particular type of limit. What type of limit? Limit of this quotient function. This is something like quotient, right? Because
Yes,
here limit is depending on h. So that's why this is again a function of h, and this is again a function of h. So a particular type of limit, if this limit exists, then we say that our function is differentiable at that particular point x. Now what happens? Sometimes we want, sometimes function is differentiable over all its domain. So then what we can do, we can take this in place of the, at place of this x naught, we replace this x naught by x and get a derivative to be as a function of x only. That means just take x itself. Then what happened? Then we know, then what we get f dash of x is nothing but this limit, that limit h going to 0, f of x plus h minus f of x by h. So now your derivative become a function which has an input, and input is what? X. So if you want to calculate the value of derivative at particular point, what you have to do, just replace this x by some point, x naught or a, whatever point is there, right? So if you have to check, yes.
As per this, mod x is, the limit exists at 0.
No, limit does not exist for mod x. I'll come to you and I'll get back to that example, particular example mod x. Okay. So this is a particular thing that we convert our derivative at particular point. First what we do, we define derivative for a single point. And after checking at all points of domain, we describe derivative as a function of something, right? So now what happened? If we have some function, for example, mod x, right? F of x is equals to mod x. And we have to check that is it differentiable? Is it differentiable at x is equals to 0 or not? That means what we have to check? That means we have to check is this limit h going to 0, f of 0 plus h minus f of 0 by h exists or not, right? And whenever limit is there and mod type of function is there, because mod x is what? Mod x is this function, right? This piecewise function. It will be x when your x is greater than or equal to 0, and minus x when your x is strictly less than 0. So whenever we have piecewise type of function, for determining that limit exists or not, what we will do? We will use the left hand limit and right hand limit concept, right? So if you assume this this whole function to be some another thing, let's, for time being, let's assume this is some function g of h. Because h is the only variable here, right? So if we assume this to be g of h, then what happened? We have to find out that this limit exists or not. What we have to do? We have to take that left hand limit of g of h is equals to right hand limit of g of h. This thing we have to check, right? So if we take particularly left hand limit of this quotient, what will be that? So take the left hand limit of that quotient. That left hand limit is nothing but limit h going to 0 minus, because we know that whenever we talk about left hand limit, we use this minus sign. This minus sign says that your point is being approached from the left hand side, right? Left hand side of the 0. So we use this thing, and this will be h. This will be f of here we have 0. So let's talk about general case only. After that, we'll come back to particular example. So this is x naught. Let's say x is equals to x naught. We are talking. Okay, so it's x naught plus h minus f of x. Right. Now this limit can be evaluated in this fashion also. That limit h going to 0. In place of that quotient, what you will do? We will take the left hand side of that quotient. For you guys, it is a little bit trickier to understand why this left hand limit come to be that, but let's take this thing, x naught minus h by h. Actually, there is a one geometrical explanation for that. So we'll come back to that later. So this particular limit. So actually what happened, this is left-hand limit, right? This is the general left-hand limit we wrote for any firm. So this general left-hand limit actually equals to this limit. Here what happened? The sign got changed. I mean, f of x naught will be there and minus of f of x naught minus h. In place of f of x naught plus h, this minus sign will be placed. In terms of what we are doing, we are just replacing h by minus h so that whenever we h goes to 0, that minus h quantity will actually take your all points from the left hand side. That means if h goes to 0, then if you take minus h, then minus h also goes to 0, but it approach from the left hand side. That's why what we did here, we just took h to be equals to minus h and change our whole limit. So now this left hand limit is actually equals to this particular, right? So at the end, what we get that the left hand limit of that quotient is actually equals to this limit, that limit h going to 0, f of x naught minus f of x naught minus h upon h. And this particular limit is known to be the left hand derivative, right? This particular limit, this h going to 0, f of x naught minus f of x naught minus h, this is said to be the left hand derivative. And similarly, with the similar process, if we approach 0 from the right hand side, then what happened? We just took this limit only, that limit h going to 0, f of x naught plus h, because here we just took h to be h itself and we are approaching 0 from the right hand side. So f of x naught plus h minus f of x naught by h. So now this particular limit is known to be the right hand derivative. Okay. So you guys should remember these two limits, because whenever we have piecewise function, mod function, or greatest integer function, or any function which is defined in some broken piecewise thing, that means either x is greater than a or x is less than equal to a, this kind of thing. And if you want to check differentiability at a point A, then you have to use left-hand derivative and right-hand derivative concept. Okay. So these two limits are fine for everyone, right? Is there
Yes,
any
ma'am.
doubt? So let's
No, ma'am.
state the
Ma'am,
formal definition.
One thing,
Yes.
if you just scroll up, can we rewrite this left-hand derivative as f of x naught minus f of x naught plus h divided by minus h when h approaches from 0 minus?
But here there won't be plus. This should be minus 1.
No,
You can write it.
I'm right.
If you take
h is
minus.
approaching from 0 minus.
Just. That's the thing. You can, I mean, many places they wrote in this fashion only because they take f of x naught at certain thing. But I mean, I am familiar, I'm able to understand this. First, we do f of x naught plus h minus f of x naught. And then at left-hand derivative, we do f of x naught minus f of x naught minus h. That's why I wrote it.
No, ma'am. What I am saying is that we replace this minus inside x naught minus h. And this h is approaching from 0 minus, and we have a minus h in the denominator. That's, I think, what I saw in the book. I mean, if you just write it down, it says limit h approaches from 0 minus.
Limit h approaches from 0 minus.
F of x naught minus f of x naught plus h.
Upon minus h is there, right?
Yes. Yes.
So what we did, we removed the 0 minus. That's why we get this limit.
And also you switched h to h minus h. You replaced h with minus h.
We replaced h with minus h. Then what happened? This 0 minus will be gone and this limit will become limit h going to 0. F of x naught minus f of x naught minus h will be there. And now here will be plus h, right? So same thing is happening, right?
Yes.
Yeah. So thus what we get at the end, we get f is differentiable at point x is equals to x naught if limit h going to 0 f of x naught minus f of x naught minus h upon h, this is equals to limit h going to 0 f of x naught plus h minus f of x naught by h. That means whenever the left-hand derivative is equals to right-hand derivative case happen, we say that that function will be differentiable at that particular point x0. So let's verify our definition for mod x. So let's say f of x is nothing but mod of x, right? Then at x is equals to 0, we want to find that our function is differentiable or not. Okay. So what we'll do, we'll try to find out left-hand derivative. So left-hand derivative is nothing but limit h going to 0. This will become f of x naught, f of x naught, right? So that means f of 0 minus f of x naught minus n. That means 0 minus h upon h will be there, right? So this is nothing but limit h going to 0. F of 0 is 0 because mod is there. So that's why minus of f of minus h, right? So f of minus h is there. And we know that f of x is equals to mod of x. And this will give us the positive quantity because this is x when x is greater than or equal to 0 and minus x when x is less than 0. So that's why this minus sign won't be there. It will become minus of h. This minus sign will be there. This minus h. F of minus h will become h only. Okay. So this thing will happen. So what we will get? We will get minus because h and h will get cancelled out. We get minus. Did I miss something here? No, right?
No, ma'am.
Okay.
Now if we do, I think I missed. Okay. If we do limit h going to, fine, it's fine. Limit h going to 0, f of, we are doing left-hand derivative, right? Now we have to do right-hand derivative. So right-hand derivative is limit h going to 0, f of 0 plus h minus f of 0 by h. So this will be nothing but limit h going to 0, h by h, right? So it will come out to be 1. So that means here left-hand derivative is your minus 1, which is not equals to your right-hand derivative, which is equals to 1. So that means at x is equals to 0, the differentiability is not there. That means the mod function is not differentiable at x is equals to 0. Is this example clear to everyone?
Yes, ma'am.
And it is also not continuous, right?
No, it is continuous. Continuity is there, but differentiability is not there. You said continuity, right? Continuity is there because by the graph you can easily observe that it is continuous or not.
Ma'am, can you
Mod of
please
x is
scroll
there.
up a little bit?
Yeah. Still?
Yes, ma'am. It's done. Thank you, ma'am.
Yeah.
Ma'am,
This
something.
you have to keep in mind always for differentiability. Okay. Sorry, what?
Ma'am, can you please show that once again?
Show the what? Definition. Okay.
Should there be one more condition? They should be finite. LHD and RHD should be finite.
Yeah. Not equals to infinity.
Ma'am, can you please explain the LHD again, left-hand derivative?
Yes. I'll share the PDF if you guys are taking notes.
No, I want you to explain the LHD while
Like
f of
before
minus
the qualifier.
is h.
See, the relation between differentiability and continuity, right? So the whole simple condition that if f is differentiable, at some point x is equals to x naught, then f will be continuous at that. Differentiability implies continuity, but the other way around is not true, right? So, but the converse is not true. The basic example of that is f of x is equals to mod of x. Mod of x is continuous at 0, right? So it is continuous at x is equals to 0 because you can observe by the graph only. This is the graph. So continuity is not breaking anywhere. Right? So this is a graph of mod of x. So mod of x is continuous at 0, but not differentiable. Right. So differentiability implies continuity, but continuity does not imply differentiability. That means differentiability has much power than continuity. Okay, is that clear?
Yes, ma'am.
Ma'am. just like before the qualifier 1, I think you only shared the previous year questions for practice.
Okay. Okay.
Would you share also this time?
Okay. I'll share that file also. Yeah, at the end I'll share that file.
Ma'am,
Huh?
in LHD, I did not understand why minus h will become f of h.
See what happened. We have to convert this limit h going to 0 minus sign, right? This minus sign is there. So that means what we have to do, we have to approach 0 from left hand side. So that's why we just took minus of h and let h going to 0. Because as h goes to 0, minus h will approach 0 from left.
Okay. Got
So
it.
we just use this concept, and here we assume that our h is a positive quantity, h is greater than 0. Okay.
Okay, got it.
Ma'am,
Yes.
ma'am, there is a similar question in activity 8.3 wherein we are actually asked to find there is a function which is equal to x into mod of x, and we are asked to find whether it is differentiable at x greater than equal to 0. So ma'am, when it is not differentiable at 0 mod x, then how come we can say that? Because
It
the
is
answer
differentiable
shows
at
it's
x greater than or equal to 0.
yes, ma'am. The question, there is an option with that, and that is the correct option.
Question number?
Question number is 3.
Activity 8.3, right?
Yes, ma'am.
Any point other than 0, it does not change the direction. So it is differentiable.
But it's asking for x greater than equal to 0.
If it's not differentiable at any point of r.
Either greater than or equal to condition can be true. If greater than condition is true, then it will be okay.
Yes.
There is a
Yeah, this
similar.
function is actually differentiable at x is equals to 0 also, and every other point.
Ma'am, that when you take the differential, when you find the derivative, ma'am, actually it's not. I don't think the derivative, because in the denominator we are getting mod x after finding the derivative.
In the denominator you are getting mod x.
Yes, ma'am.
Okay, we'll solve this question at the end. So let's
Sure, ma'am.
don't
Sure.
break for a flow.
Okay,
Yeah.
ma'am.
Just discuss some rules of differentiability and then we'll. Okay, so this
ma'am,
is basic
whenever a
definition.
function is splitting, like you said, for differentiability, we have to prove the LHT and RHT, right? And they should be equal.
Right. That will be the standard procedure. I mean, if the function is piecewise, then they want you to use the LSD and RHT. Okay. Now, there is one more alternate formula for differentiability, similar thing, that f dash of x is equals to limit x going to x naught, f of x minus f of x naught upon x minus x naught. This is one other kind of limit used for checking differentiability. Right. So this formula and that formula is similar. In that formula, what we do, if you replace x minus x naught with h, you will get that limit. This limit h going to 0. Okay. So in some time, what happened in calculation, this limit will be much more easier to compute, irrespective of that limit. This is x naught plus h minus f of x naught by h. Right. So at some point, this limit is very helpful for computing this above one, because it just contain a function at single point, right? Here x naught plus h is there. So if you have some polynomial, then this x naught plus h to the power will be more tough to handle. So that's why you can remember these two limits, where whatever you feel comfortable, you can use both of them for checking differentiability. Okay.
I'm asking because it is the first time I've seen that formula. Even in the TA sessions, we weren't taught about that formula.
This formula.
The above
yeah,
one,
I'm
the
just
LHT one.
In the TA session, he gave that minus h one in the denominator.
That's why I mean at some point what happened now, this limit is much easier to compute. So if you feel stuck with, first choice will be this one only, the quotient one only. This is your first choice.
This was the one that was taught to us. Yeah.
This is your first choice. If at some point you find out that the calculation is becoming very much trickier or tougher, then you can go with this limit also. This limit is very simple, right? Simple to remember also. F of x minus f of x naught upon x minus x naught, right?
Ma'am, it is for RHD.
This is for everything. RHD, LHD, you can easily compute just by taking the left hand limit of this limit and right hand limit of that limit, right? So both things can be up. Just keep in mind, if at some point, if you find out, it's better to know, right? In this limit and that limit, there is nothing, just a substitution, right? X minus x naught is equals to h. If you put, then you will find out this limit from this limit. And if you do the vice versa substitution, you can get both of them.
Can you take an
I'm just giving
example,
you for your information. Example I don't have at this time. Let me see. Okay, then we will. Now let's move towards. Okay, left hand derivative, right hand derivative.
Ma'am, one more thing. Actually, someone in the chat box asked one question that if the derivative of a particular function goes to infinity, then what can we say? Like, it is differentiable or not differentiable? I was confused.
No, it's not differentiable. Not differentiable actually. Because
okay, like the tangent function.
So what happened at that point? Okay, we haven't talked about tangent yet. That's why I'm saying something. So you have to take care that both things will be fine.
It's a divergent.
Diverging. Your tangent will become parallel to y-axis. So such kind of thing happen. That's why we say that.
The meaning is very simple. The meaning is very simple. LHD is infinite, RHD is infinite. We cannot compare these two infinite to be the same.
Yeah, that will be one thing. Right. So now there are some easy formulas. So I will suggest you guys just go through your textbook. The basic formulas to differentiable polynomials, right? This type of formula, that d by dx of x to the power n is n x to the power n minus 1, and all those kind of simple formula. Just go and try to learn. Okay. And let me go towards the what we say algebra of derivatives. Right. So suppose f and g are two functions. F and g are differentiable functions. Then you guys are familiar with this notation that f dash of x, this is same as d by dx of f of x, right?
Yes,
these two notations are same. So what happened when we try to find out the derivative of addition or subtraction of two functions, then the derivative will get distributed over each term, right? D by dx of f plus g, same as d by dx of f plus or minus d by dx of g. So over addition and subtraction, it is quite easy, and also over the constant multiplication. So if we suppose c belongs to real number is any constant, then d by dx of c of f is same as c d by dx of f. The constant also you can take outside of your differentiability or derivative. Okay. Now here come the product rule. So product rule means if you have to differentiate the product of two functions, then there is a certain rule which we have to follow. That means that the d by dx of product of two functions f into g is actually equals to d by dx of f into g. That means first differentiate f and then multiply it by g and then add f into derivative of g, d by dx of g. This is known to be the product. When you have to find out the derivative of a product of two functions, then you have to use such kind of rule. Okay. Now the next is quotient rule. Actually, you can obtain quotient rule using the product rule only, but you have to remember that d by dx of f by g is actually equals to g square g into d by dx of f minus f into d by dx of g, right? So that means at the denominator, you have to take the square of that function, and then numerator, you have to take the numerator function and then multiplied with the derivative of what we can say numerator, denominator, all those kind of things. Okay, so these two are very basic formulas for differentiability. Whenever you have some complicated function, for example, e to the power x sine x into x cube, right? So in such kind of function, you have to use a product rule. That will be much easier. And if you have some kind of function that e to the power x upon 10x type of function, right? So in such kind of function, you can use a quotient rule to find out the derivative of that particular function. Okay, is that clear? These are just a function. You have to mug it up and remember. That's okay. Now let's come to very important rule, which is known as to be the chain rule, or differentiability of composite function. That means if you have two composite function, then how can you differentiate these two functions? Okay. So the dy dx of f composite g of x is actually equals to, you have to do d by, first you have to differentiate the outermost function f and take input to be gx and then multiply it by the derivative of gx. Right. So this is known to be the chain rule. So chain rule is very important because these three rules are only used for finding out the derivative of any type of function. Any type of combination can happen only you can use these three rules to compute it. For example, if you have to, I'm just taking very easy example, that if you have to compute the derivative of f of x of e to the power x square, then what is this? This is actually a composition of two functions. First function you can take f1 of x, you can take e to the power x, and f2 you can take x square, right? Then what is f of x? So f of x is nothing but f1 composition of f2 of x, right? Because if you solve this thing, what you will get? You will get f1 of f2 of x. But what is f2 of x? f2 of x is x square. So that means this is e to the power x. So here, if you want to find out the derivative of e to the power x square, you just apply chain rule. So that means d by dx of fx is nothing but d by dx of f1 of f2 of x. That means input you have to take f2 of x into d by dx of f2 of x. You guys are already know, I think, that the derivative of e to the power x will be e to the power x only. That's why here it comes e to the power x. But since our input is f2 of x and f2 of x is equals to x square, that's why this thing become e to the power x, right? And into d by dx of x square, and this is nothing but 2 times
2x.
So this is the chain rule. So if there is some computational question based on differentiability, then you can solve that question using these three rules only. You don't have to remember any other. Yeah, obviously the basic formulas, what are the derivatives of functions. Okay. So that's the thing I have.
Ma'am, could you explain the chain rule once again?
Yeah, sure. So in chain rule is what? Chain rule, if we have composition of functions, then how can we find out the derivative of such type of things, right? Activity question. Yeah, we'll go through the activity question also. So what do you, that means if we have to find out d by dx of f composite g of x, then what you have to do? You have to first differentiate the function f and take input to be g of x. Here what we did, that first we differentiate, first we will observe that d by dx of e to the power x is e to the power x. But instead of x, I took my input to be f2 of x. f2 of x is what? X squared. That's why this thing will become e to the power x. That means in chain rule, what you have to do, you have to differentiate the outermost function and take the input to be the inner function, that means g of x, and then multiply it by the derivative of g of x, right? Here you don't have to, if you get confused with the input thing, what you can do, first find out the derivative of f and then replace x with g of x and then put it out. First thing what you can do, just say it to be t and just find out d by dx of f of t into d by dx of g of x. And after finding out the derivative, just replace t by g of x. That will be easy. Okay.
Okay. Yes, ma'am. Thank you.
Yeah. Now let's move toward the tangent and linear approximation. So first I'll cover linear approximation. So linear approximation means what? So if we are given some certain behavior of function over some region, and if I want to find out the value of function after that point, after that particular point, suppose this is your point a comma f of a, and it's already given that how function behave till the point a, and after that point I don't have any information that what will be the, after that point we don't have any information that what are the values of functions. So but here we also have one information that f is differentiable at x is equals to a. Then what we can do, we can approximate our function. What do you mean by approximating? We can guess the value of function near this point, near the point a. What will be the value of function near this point? This is x is equals to a. Then near the point x is equals to a, how my function will behave. We can, at some error, we can approximate. And for approximating, what we do, we just say that our function is behaving like a straight line. For example, suppose this is your point A, and it is given that the function is differentiable at a point A, and they ask what will be the value of point f of x, and this is your point x. Okay, and this is your A, and this is your x. So what we can say, okay, my function is just behaving like a straight line in between, I mean, very closer to the point A. That approximation by a straight line is known to be the linear approximation. So if I'm saying that my function is behaving like a straight line over this function, then that means the equation of function is actually given by a line. And you know that equation of line we can obtain via just finding the two information. First thing, the point where the line passes through, and second thing, the slope of a line. So what we'll do, we'll take point to be x, this point, a comma f of, I mean, what we'll do, so we will approximate our function with function by the line which passes through the point a comma f of a, and it has slope, and we use the knowledge of differentiability at a point x is equals to n, and we say we will approximate our function via a line which passes through the point a comma f of a, which has a slope f dash of a, right? Because that will be the slope of tangent. And what is tangent actually? So tangent, you can roughly understand, it will be a point, it will be a line which passes through exactly one point, which is situated on your graph. For example, if this is a point, then this will be that. It touches the graph exactly at one point, and it will show how your graph is actually moving. That line is known to be the tangent line. And it turns out that the slope of tangent line is actually equals to the derivative of function. So that's why what we did here, we approximate our function via a straight line, and we assume that that straight line actually passes through the given point and which has a slope f dash of. So now we just have to use what we say equation of line, right? So equation of line is what? Y is equals to this will be y naught plus slope is there and x minus x naught is there. If a line passes through a point x comma x naught with passes through the point x naught comma y naught with slope. So we just replace our known quantities. So we say that f of x is actually equals to y naught. So y naught is what here? F of a. F of x is equals to f of a plus f dash at a x minus. Now this is the linear approximation of function. Linear approximation of function f at x is equals to a, right? So if someone asks what is the linear approximation of a function at certain point, then this will be your answer. F of x is equals to f of a plus f dash at a into x minus a. Is this linear approximation clear? Is there any doubt?
No, ma'am.
No, ma'am.
Ma'am, we are dealing with the curve at micro level here.
Yeah, we are just we are approximating it very near, because it can happen that as you move as you move away from your point, then the error will become much higher. That's why we say that it will be a little bit closer to your point.
Ma'am, we have to just differentiate the function at that particular point.
F dash at a, we need differentiability at that point. If you want to approximate our function via linear approximation, then we need differentiability.
Okay.
Yeah, because if you don't have differentiability, then we don't know that how our function will look. Right? Differentiability gives us a little bit information. Okay, tangent is there, so you can approximate via straight. If we don't know that tangent is there, then it will be much difficult, right? For example, if I,
Ma'am, the direction of the line will be in the direction of the tangent here, right?
Right. Yeah, since we are talking about line, so direction doesn't matter that much.
Yeah, direction doesn't matter.
It will be approximately like tangent. The line will be approximately like tangent the way.
It will be approximately like tangent, but yeah.
I think it is the tangent.
Actually, this is the this is actually equation of tangent pass at point
That
x
point.
comma f of x.
Yes, ma'am.
That's why
actually equation of tangent only.
Ma'am, like
So,
if we are
like
dealing
we
at
have-
micro level, ma'am, then of course that point we will differentiate that will equal to tangent. Then of course the straight line will be equal to the tangent.
No, so what happened now? There will be some error. Error will be very less, but there
yes,
will be
ma'am.
some error. So
Since it is a curve.
Hello, ma'am. Hello, ma'am.
Yes.
Ma'am, the tangent at a point is synonymous to the differentiation of that function at that particular point, now.
Actually, tangent and differentiability has a very
Differentiation.
very similar things. Since it is differentiable at that point, so that's why the tangent will exist. It will be unique, and this will be the equation of tangent. Right?
No, ma'am, if I want a tangent at a point, then I differentiate a function and then put that point in the differentiated function, then I'll get a tangent at that point.
Will be no. That will be your slope.
That will be
of
the
tangent,
slope of
not
the
tangent.
What?
So actually, the derivative at certain point will give us the slope of tangent, not tangent, because that's the one observation of derivative. For example, if this is your function, suppose this is your function. Let's make it a little bit clear. And this is your point Q, and this is your point P, right? So what happened? This is your secant line, right? So if you approach towards the point P, now this secant line will become your tangent, right? This observation, I think you already heard. So then what happened? The slope is actually given via this ratio, that f of x naught plus h minus f of x naught by h, right? This will be the ratio for this secant line. And if you approach the limit here, then this will become your f dash at x. Okay, it's a very physical phenomena. So that's why, because of this reason, they say that tangent actually, the slope of tangent line is actually given by the derivative of that function at that particular point. You can read this description into Thomas calculus. Is there?
So, ma'am, we can only find from the equation you have written here, fx is equal to f of a plus f dash a x minus a dash.
This is actually equation of tangent, and derivative at particular point will give us the slope of tangent only.
So, ma'am, first we calculate the slope, and then we will write the equation of tangent. Is it correct?
But yeah, in some sense it will be correct. But what happened now? See, there is one very.
Ma'am, please take an example of polynomial function or any other function and calculate the value.
See,
it will be.
Suppose if your function is like this, it is concave first and convex after. Suppose this kind of function you have. Then what happened now? At this point, you can't able to draw a tangent, right? Because if you draw any line, either it will get cut by the graph, either it will cut the graph, or it will become parallel to y-axis.
Yes.
Right? So in certain scenario, what happened? The function will be differentiable at there, but you can't actually find out the tangent thing. Tangent means it should not cut the graph.
Sorry,
That thing we already. So this concept you will learn when you learn about the maximum value, minimum value, and all those things. There, I think sir discussed this type of thing. That at certain points, what happened? The function will be differentiable, but it's very tough to draw a tangent. So in certain scenario, tangent won't exist, but the function will be differentiable. This is one scenario.
X cube will not.
Such kind of a point actually known as to be the critical point. I think you are familiar with such point. Where the function neither took the value maximum value nor minimum saddle points and all those things. There
But
such
at
type
the
of
critical point, can we calculate the value which you have discussed above?
At the critical point, we can find out that line. Line will exist, that's sure. But it won't be the tangent line. It actually cuts the graph. And the tangent line won't cut the graph.
Okay, now
that's the thing. Okay, fine. So that much we have to discuss from week 8. Now let's do a couple of examples.
Can we start with the linear approximation?
One.
So
we have one from solve with us. The last question.
So can you share that screenshot in the chat box, because solve with us I don't have.
Ma'am, tangent is left. Maybe I think so.
Tangent is.
Ma'am,
discuss. This is only the tangent now. Tangent you don't have to. I mean, they won't ask find the equation of tangent or something else because it's equal to the linear approximation only.
Ma'am, which kind of question they guys are asking in quiz 2?
Based on all the topics we taught. So, I mean, you will get some idea from practice and graded, right? We can't make any different kind of question in this, right? Because it's just limit, continuity, differentiation. So we'll give you some function. We just ask whether it is continuous or not, differentiable or not. One thing is, you guys are familiar with L'Hospital rule, right? Haven't discussed it?
Yes, ma'am.
Yes, ma'am.
Yes.
L'Hospital rule, what does it say? That limit x going to a f of x upon g of x. So if you will get 0 by 0 form or infinity by infinity form, what you will do, you will change. I mean, this limit will be then equals to limit x going to a. This took a derivative then f dash at x on g dash. Okay, so this is the L'Hospital.
Okay, ma'am. Could you please explain sandwich principle?
Sandwich principle. Sandwich principle for
theorem.
Limit or sequence. So sandwich theorem actually what says, if you have 3 type of sequence, suppose you have an, bn, and cn, in such a way that an is less than equal to cn is less than equal to bn for all n belongs to natural number, and these two sequence actually converges to same limit. That means limit limit n goes to infinity an is same as limit n goes to infinity bn, same as some n. Then this condition actually implies that the limit n goes to infinity of cn is also equals to. It means what you are doing, you are sandwiching your sequence into some sequences. For example, graphically you can observe. Suppose this is some cn, right? So if an and bn in this fashion, then obviously your cn should have to converge at that particular, right? Because it should stay between these 2 points only. So such kind of behavior, this theorem is known to be sandwich rule, right? Is that clear?
Ma'am, can you please explain this sandwich theorem once again?
See what happened in sandwich theorem. One thing, this is you want to compute, right? So what you will do, you will try to find out 2 sequences, an and bn, in such a way which actually somewhat sandwiches your value of sequence. That means the value of cn should lie between the value of an as well as the value of bn. I mean, it should become, trapped between these 2 sequences. and you have to find these an and bn in such a way that they are converging to the same limit. So if you are able to find out such a sequence, then you can say that this sequence, this Cn, also converges to that particular limit only.
Ma'am, sorry to interrupt
Is that
you,
clear?
ma'am. Ma'am, if you
Okay,
have
ma'am.
related to this thing, could you please solve that example in front of us so that we can grab it in very precise way?
Which question?
Ma'am, for sandwich principle.
Yeah, ma'am, on sandwich theorem.
Can I make a suggestion?
Yeah, sure.
You take the example of sin x by x square. You can easily show that using this principle that it comes to 0.
Yes.
Although sin x by x square or sin x by x are also fine.
No,
Right?
x will be
Because sin
difficult,
x by
no?
x is also.
For a sandwich, x square is the best. There is a reason for
Fine.
that.
Again,
Basically the
sin x.
inequality will be sin x greater than -1, less than 1.
Yeah, -1 upon x square will be there and 1 upon x square will be there. Right?
No.
So this converges to 0 and this also converges to 0.
Yes.
So
Since these two are going to 0, this also will go to 0.
This also goes to 0.
That's the way that.
So ultimately for sandwich theorem, you have to come up with these two types of sequences.
Correct. You need 2 more auxiliary sequences which are on either side.
So let's go through this question. So let f of x is differentiable at x is equals to. Okay, so here what does this say? So here 2 points is given to you, right? 5,8 and 1,0. I'm talking about the question which were posted. This is the question, right? So in this question, what does it say? That first thing is our function is differentiable at point x is equals to. And f represented by a curve C, if a line which passes through this point, this 5,8, is the tangent to the curve C at point 1, 0. So that means if that line which is passing through the point 5,8 is a tangent to this point 1, 0, then that line should also pass through the point 1, 0, right? Because what do we mean by tangent? Tangent means it touches the graph exactly at that point. So that means this line L, which is passing through 5,8, should also passes through 1, 0, right? And whenever you have 2 points, you can use the equation of line y minus y1 is equals to this equation of line to find out that what is your equation of line. But although if you have 2 points, then you can easily find out the slope of this line, right? Slope is what? This is y2 minus y1 upon x2 minus x1. So you can treat any one of them to be y2, y1. So let's say 8 minus 0, 5 minus 2. So this will become 8 by 4, which is equals to. That means the slope of this line is actually equals to 2. And it's already given that this is a tangent line. And we know that the slope of tangent line is the derivative of that function. So that means this is equals to f dash at 1. So we got the value of f dash at 1. And this is equals to 2. Okay. So is this clear? Here just you have to here just you have to remember that the slope of tangent line is equals to the value of derivative at that particular point.
Yeah.
What's the role of points then?
Points plays a role now. If you don't have 2 points, then how can you find out the slope? This point is important because of the line thing. Because if we just have 1 point, and if they won't give that at which point is the tangent is, passing through at which point, then that will be, we can't find out the slope of line. We need either 2 points or we need any information about line other than this to find out the slope, right?
Okay.
So someone, let me solve.
Activity questions, ma'am, will you take today, ma'am?
Like the last question, if you substitute by 8 at y, and x by 5, then also you'll get the answer, right? F1 is 0, already given that 1 0 point, right? So there F1 is 0, and you substitute y equal to 8 and x is 5. 5 minus 1 is 4 and 8. So F1 comes to 4. Something like 2, sorry, 2.
Yeah.
That's the actual reason why the hint was given.
Oh, this hint, I haven't observed it. Okay. Yeah, you can go through the hint also. So I have one question.
Can you take 2% just from practice assignment? Weekend.
Yeah, I can take, but let me do one example. Okay, so one thing I want to say about graph, and if some graph is given to you, then how can you judge the derivatives, right? So first thing, if you guys are, I think, already familiar, if there is a corner, right? If there is a corner, then at that point function won't be differentiable, right? If there is this type of corner is there, then at this point the function won't be differentiable, right?
Yes, ma'am.
If this is a, then at x is equals to a, f is not differentiable.
Ma'am, this point will have two tangents, right?
It has infinitely many tangents actually. You can't draw a unique tangent, right? This line will be tangent, this line will be tangent, this line will be tangent, right? So that's the reason for corners. Okay. Now, second thing, that whenever your tangent will become parallel to some axis, for example, in this kind of scenarios, right? If this is your graph, then at this point, x is equals to 2, suppose, your tangent is actually becoming parallel to x-axis, right? This is
allowed.
This is allowed because it satisfies all the conditions. No?
It should not be parallel to y-axis.
It should not be parallel to y-axis, because every line which is parallel to y-axis, we can't talk about slope, right? So it should not parallel to y-axis, but it can parallel to x-axis, right? So if this is your tangent, then this answer, what can you say about the slope?
0. 0.
Right. Correct. So that means the slope is equals to 0. So that means the value of derivative at that particular point is 0. So these 2 points I want to make. Any other? Yeah, that's all. So by a graph, you can say that if the corner is there, then obviously it won't be differentiable. And also if it is discontinuous, then obviously, right? If this is your graph, then at x is equals to 5, it won't be differentiable, right? Because it is neither continuous. So how can it be differentiable? This thing is also clear, right? Because again, there will be infinitely many tangent type of thing, or continuity is not there. So there's no point to talk about differential. Okay. These three
There will
cases.
be a hollow circle either of the first graph and or on the second graph.
I mean, it depends on the function. Suppose this is hollow, because then function would be different.
Yeah, one more thing. When can we say a function is bounded or unbounded?
Bounded, unbounded. Have we discussed bounded, unbounded functions?
Yes, ma'am, we have discussed. Simply, if the limit of either side tends to infinity, is unbounded.
Right. Via limit, you can say. So bounded function means what? So you, you have to find a number which can bound all the values of function. That means there should exist an m belongs to real number in such a way that the values of function should lie between this bound m. That means there should exist some such kind of link. If we are talking about graphically, then this line is y is equals to m, y is equals to minus m, in such a way that your all graph will lie inside this box only. Like this vertical, this rectangular thing.
And they
rectangular
exist
string.
between any range, like suppose from 2 to 4, if a function is
any
between...
range. Right. You can take any, I mean, it's not necessary this will be minus m, it could be anything, but you can find out a particular number for which your graph will lie between this
infinite number.
Right? Finite number. So that function is known to be the bounded function. Okay.
It must be
One
in
way
range.
is, sorry, what?
Like whatever the range is given to us, it must be under that only.
Yeah, obviously. If range is given to us, then range should be finite.
Like sin x function.
Sin x function is the very, fine example.
Ma'am,
So this is one bounded function. Yes.
How can we say a function is bounded on R?
Bounded on R means this is the thing, bounded on R. That means you can take any real value, x is equals to, let's say, 10 to the power 9 or something, minus 9 or something. I mean, you can take any much larger value as your input, but your output should lie between certain range. Please mute yourself. Okay, is that fine, Siddhi? I mean, you can take input to be much higher or much larger value or much lesser value, whatever you want to take, but your output should lie between certain bounded range. That's why they say that it will be bounded over R. Okay. The other thing is to find out it is bounded or not, is to talk about these two limits, limit x going to infinity and limit x going to minus infinity. If these two limits are finite, then we say that our function is bounded. Why can we say? Because if these two limits are finite, then you can easily draw a strip in which your function will be.
Ma'am, can you please take
these limits
of activity 1? It is about the thing you are explaining.
Activity 1, 8.1.
Yes, ma'am. 8.1, question number 8.
Ma'am, you better go activity wise, ma'am.
Okay, so yeah, okay, fine. So let's go through the activity. I think. So 8.1, which question you asked?
Question number 8.
So here you have to find out the limits only, right?
I have question 5 also.
Let's in the question number 8, what is given that at particular x is equals to 0, value is given, but at x not equals to 0, it's given some function into e to the power 1 by x, right? So what you have to do, you have to find out the limit of that function at x is equals to 0. That means you have to find out limit x going to 0 of 1 upon e to the power 1 by x plus 1, right? So here you observe that as limit x goes to 0, this will goes to infinity, right? And if this is infinity, then this limit will become 0, right? So that means this limit is nothing but 0. So that means this limit is finite. So that's why this function will be bounded. No, wait a minute.
So basically means that if a function is unbounded, then we cannot find any limit.
Yeah, not any limit. Actually, here what happened, this we take a particular value x going to 0. Why we took that? Because if you take let's talk about, because from this we can't say about boundedness. For boundedness, if you want to talk about, you have to take this limit. Either limit x goes to minus infinity and limit x goes to plus infinity and minus infinity both. Okay, so you have to compute these two limits for saying boundedness. Right, because again as x goes to infinity, this will become e to the power 0, right? Because 1 by infinity is 0 type of thing. E to the power 0 will be a finite thing, so it will become 1 by 2, right? That means finite. And similarly, 1 upon e to the power minus 1, 1 upon x plus 1. Next, x goes to minus infinity also, this will goes to 1, right? Because e to the power minus x is there, right? So again, the whole thing. will go to 1 by 2. That means again finite. So if you want to talk about boundedness, then you have to compute these two limits, not any other. These two. Limit x goes to infinity, limit x goes to minus infinity. That's it.
Then the modulus of these two values. No?
Then if you take modulus of these two values, that will work for your steps. Okay, for these two steps.
So how can we are bounded?
But one thing I want to say that this will happen in case of continuous function, not for any function. Okay, in case of continuous function means if you are sure that your function is continuous at every point, then you will find out these two limits and say that your function is bounded or not. One example I'll give. For example, this is your function. Right? This is your function. This is actually basically 1 upon x function, right? F of x is equals to 1 upon x.
Then question number 5.
Just state this fact. So what happens when you have continuous function over all your domain, then you will find out these two limits, and if these two limits were finite, then you can say your function is bound, right? But if your function is not continuous, in this case, if f of x is equals to 1 by x, you can easily check that at x is equals to 0, the function is not continuous, right? So that means function is not continuous all over. In this case, limit x goes to infinity, f of x, as well as limit x goes to minus infinity, both limits are equal to 0 and both are finite, right? But still function is unbounded because function is not continuous at that particular point because of this nature, right? It's actually growing up.
The left hand side will be on the third quadrant.
ठीक है. Concept ठीक है. Negative तो negative value की तरफ. Yes. Yeah. Still, point is, what I want to say that if function is continuous, then only you will compute the limit, you will find out. But if function is not continuous, then there will always some uncertainty at those points where function is not continuous. There you have to take care of limit. For example, here at x is equals to 0, function is not continuous. So that's why at x is equals to 0, you have to explicitly check what's happening there, what's happening in the neighborhood of x is equals to 0. After that only you can tell that function is bounded or not. Okay. Which question? Question number 5, right?
According to the given, it is not continuous but bounded on R.
It's also bounded now. We just computed the limit x goes to infinity and minus 2. It turns out to be 1 by 2. That means finite. So it will be bounded. Right? Question number 5.
But ma'am, it is not.
Option is true. Sorry, what?
But it's not continuous.
No, it is continuous, no?
According to the answer.
Sorry, it is not continuous.
It is not continuous. You don't have to be continuous.
But it is not continuous. But although this actually based on a bit of observation also, because 1 upon something. I mean, whenever you have rational function which behave like px upon qx, so unboundedness will happen when your qx will become 0. So here it turns out that your qx e to the power 1 by x plus 1, it won't be equal to 0 at any cost, right? Because its exponential function is there and addition with something. So such type of, you have to observe boundedness and unboundedness, not that much easy. There are several cases. So here you can observe that, okay, it is not continuous at 0, but still at x is equals to 0, this function can behave a certain way. Is that fine?
Yes, ma'am.
Question. So the following options are true. So for such type of option, what you will do, consider either polynomial. I'm talking about question number 5, 8.1. So such kind of things you can take polynomial, constant function, and whichever continuous function you know. So whenever there exists, this phrase is happening, that means you have to find out at least one example. At most one example, not at least. At most one example, if you can find, then you can say, okay, this statement is true. For example, first statement says that there exists a continuous function f from 1 to 5 to 1 to 7 in such a way f of 3 is equals to pi. So what you will do, just take constant function f of x is equals to pi. Then that function is continuous function over all real lines. So it will be continuous over these two intervals. And f of 3 is also equals to pi because it's a constant function, right? Now again, there exists a continuous function. So for such kind of thing, what you can do, you can also make a graph, right? Continuity means what? You can draw a connected graph. Means here f of 1 is equals to 3, f of 10 is equals to 5. Suppose this is 3, this is 5. This is 1, this is 10. So you have to satisfy these two conditions, that your graph should be continuous and passes through these two things. So what you can do, you can just draw a straight line, right? This will be your graph. I mean, whenever they ask about some example that if there exists or not, then play with graphs a little bit. Continuity is what? In continuity, first thing you have to notice that graph should be your function. That means this vertical line test should pass. First thing, that function should be there. And second thing, that it should be continuous. I mean, there should not be any breaks, right? Such kind of thing you can't do. So if you want to find out the examples for continuity, then graphs are very convenient. Okay. So is this question fine? Question number 5.
Can you give me a counter and example for the same similar question for which there cannot be a continuity function? They are given two examples where it exists.
There exists a non-constant continuous function f from
we
1
can
to 1,
always
which
define
is
a piecewise function.
No. Instead of 1, 10, 2, 8, if they filled up with some other numbers, is it possible? Probably the answer is no.
Right. No. If they will give you infinitely, I mean, suppose finitely many points. I mean, if they say, first thing that function should be there. Okay. After function,
What I'm saying is,
if
for
they say,
whatever
okay,
is a number, there is always a function. I'm yet to come across a situation where there cannot be a function for that.
Where cannot be a function for that, right? That means
continuous
what? See, if there is a function, then you can always find continuous function which passes through such kind of finite. But if the input is given to you in such a way, suppose this is the input is given, that f of 3 is equals to 5 and f of 3 is equals to 8, then obviously there won't be any function, because if it is a function, it should give you a unique output, right? So if such kind of input is given to you, then you can contradict that example by, okay, there won't be any function which satisfy this condition.
No, I'm not clear. What did you say?
I said, if in those example, what does they say? They give you some particular conditions and they want to say if there exists or not. Suppose I'll give you a condition. Suppose f is a function, or let's say, suppose f is a function. Is there exist any function such that f of 3 is equals to 5, f of 3 is equals to 8, f of 10 is equals to 11,
so
and so on. If there exists any continuous function?
No.
I'm asking.
But when you said f of 3 is
your
equal to 5, f of 3 equal to 8, I mean, obviously, f of 3 has to be one unique value.
Right. So that's the thing I want to consider first. If there exists function and they have given you a finite set of points, then you can easily draw a continuous function, right? Just connect all those dots and that will be your continuous function.
It will always give.
But there isn't supposed to be a function, because it is
that's why.
one many relation actually. One many relations are not allowed in a function.
Right. So that's what I want to explain to him, that if certain finite set of point is given to you, then there always exists a continuous function. But because what you have to do, you just have to drop those points and connect it with your free hands. That will be your function, continuous function. Is that clear?
For all such questions, the answer is yes.
Sorry, what?
For all such questions, always there is a function.
But
Because
in
I
question,
already drawn, this is the function.
I agree.
This
Ma'am,
graph will represent a function, na?
Ma'am, he is asking that if we have a point, then we can always connect it. Then we will always have a continuous function. Because if we have
Yeah.
random points, then we can always connect it. There is no
I'll
chance
make it
that it will be
simpler.
discontinuous.
Questions
That's
like
the
this.
thing I'm saying.
Question like this is always having an yes answer. That's a point.
Yeah. So you are telling or
Okay.
you are asking?
ma'am, whatever points we connect, we will get a polynomial function, and all polynomial functions are always continuous.
That's the thing I want to say. If there is a
Yes.
function with the finite set of points, then you can easily join that function via your free hand. You can find out a continuous function. That's the thing I want to say. But you guys are asking or you guys are telling? I'm not getting that.
We wanted clarity, that's all. Now, if I take the first option, there exists a continuous function f from 1 to 5 to 1 to 7, such that if f of 3 is equal to 15, is it possible?
Right, you can make now. Yeah, you can make via your free hand. This continuity is what? Just a smooth drawing, which should satisfy condition of function. We should keep in mind that, okay, first it should be a function and then we can talk about continuity, right?
If it goes outside the range, maybe then we can say it is not. Yeah.
Fine.
Okay.
Let's move now. So fifth question is done. Is there any other activity? Practice assignment 8, question number 6.
Madam, in all the activity questions this time, there's like level 1, level 2 kind of questions. In most of the activities, the level 2 seems to be slightly complex. So, like, would you be randomly picking up some things from any activity?
No. You guys just message me in the chat box. I'll go one by one. Just message whatever question you want to discuss. We go one by one. Okay, that will be fine, I think. Right?
Okay.
Someone messaged me that practice assignment 8, question number 6. That's it. So one thing I want to clear that if there will be some question based on left-hand derivative, right-hand derivative, which contains modulus, then you guys are
one question number 7.
Activity 1. Okay, first let's.
Wait, let ma'am speak now, ma'am. Please continue, then take it out.
Yes, that. Speak, ma'am, first.
Okay, so what I want to say that if there exists, if they ask any question which can be solved via left-hand derivative, right-hand derivative, modulus thing, then you guys are comfortable. I'm assuming that will be fine for you, right?
Yes, ma'am.
Yes, ma'am.
You are saying yes. So most of the things, most of the people are fine with these two concepts, left-hand derivative, right-hand derivative, modulus. And if there are any piecewise function and they ask about differentiability, you guys are able to do it now, right? Correctly marked.
Yes, ma'am.
Ma'am, I have a confusion regarding 8.3, question number 5.
8.3 question number, just message this thing in chat box. I'm going one by one, otherwise we can't finish.
All right.
So let's go for practice assignment 8, question number 6. See if the function fx and gx. See this actually it's a very I can say. It's actually based on the thing that left-hand limit, if a function is continued at certain points, right? So if
which question you are talking about? Activity?
It's a practice assignment 8, question number 6. Okay. So here it's given that f and g are continuous. F and g are continuous at x is equals to t is equals to 3, right? I'm just giving you a hint because it's nothing. It's nothing there. Fine. So it's already given that the two functions are continued at certain points. What you have to do, you have to use these 3 equalities. Whenever we have continuity, we know that left-hand limit at x is t is equals to 3 is equals to right-hand limit at t is equals to 3 is equals to the value of function f of 3, and same thing will happen for g of 3, right? So you just have to use these 6 equalities to find out the relation between m and n, and then you can easily compute what are the values of m and n. There's nothing much conceptual in that question. Okay, as that will be fine for you. You can use first equalities, that left hand limit at t is equals to 3, the same as right hand limit at t is equals to 3 is equals to f of, right? If you use that limit, you can find out the value of n, and after that, if you use the later one, you can find out the value of n. Is that fine? Whoever asked this question, I think. So I'll just now go activity 8.3 question number 3. I think we already discussed 8.3 question number 3.
Ma'am, I had a quick question if I can ask. Ma'am, I have a trouble in understanding this constant continuous function and non-constant continuous function. Like, can you quickly summarize this?
See, constant continuous function means just constant function. That's all. They just written in some fashionable way. Constant continuous function means just constant function. F of x is equals to c. That's all. Non-constant means non-constant.
Ma'am, we can say a constant function is always continuous.
Always continuous, because you can easily check that too, right? Left hand limit, it will be c only, right hand limit will be c, whatever constant will be there, that. Okay. So what's your doubt in activity 8.3 question number 3?
Ma'am, the option correct option given is option number 3, but I think it should be the last option which should be correct, ma'am.
See. F dash of x is equals to 2x and minus of x. So yeah, so here for finding out f dash of x, you have to use left hand derivative, right hand derivative. No. I think so. Because what happened? It is x into mod of x now. See, let me give you just.
Ma'am, I could get the derivative, but the derivative comes out to be mod x plus x square by mod x. So how can we say that it exists at x is equal to 0?
Madam,
see, whenever you have.
So it will be minus x square and plus x square.
8.3.
Yeah. Open the modulus function. Let's open the modulus.
That's why you have to do x into x when x is greater than or equal to 0, and x into minus x when x is less than or equal, strictly less than 0. Okay, then this will become only x square and minus of x. Now what you do, whenever you have differentiable function, just differentiate it within piecewise thing only. That will give you correct answer. I mean, simply 2x and minus of x. You don't have to go through the left hand derivative. I mean, that thing also give you the answer, but there are more chances of getting confused, right? What should you use, what should not use.
But whatever you have written over here it's also true for the last option, ma'am.
Okay, so x is
ma'am, for mod we say that the derivative does not exist at x is equal to 0, ma'am. So how come we have taken 0?
No.
This
wait. F of x is equals to mod x. This function is not differentiable at x is equals to 0. But when
correct,
you multiply it by x, how?
Ma'am. So, ma'am, okay, ma'am.
So what you can do, see, if you are getting confused now, just distribute your real line over 3 pieces. First take when x is less than 0. So if x is less than 0, how your function will look? It will look x into this mod of x, right? But mod of x, how does it look when x is less than 0? It will look as minus of x, right? Now this is a simple polynomial function. So here f dash of x will become minus 2 of x, right? So this thing is clear. Okay, this domain is fine. Now again, x is equals x greater than 0, you can take. So here you will get x square. Your answer will be 2x. This thing is fine. Now at x is equals to 0, you have trouble, right? At x is equals to 0, what will be there? So here you can use left hand derivative and right hand derivative and then find the value. I think it will be 0. So that's your function f of x. So now you can define.
Ma'am, but that in that case it should be x less than or equal to 0 and x greater than or equal to 0. But the option
no, you don't have.
And that's
Okay.
where the
Option is
issue
wrong. Is the what you want to say? Which option should be correct?
The last option.
No, f is differentiable at 0, na?
Yeah, the
Why
option is framed in according to the statement given over there. It says that f is not differentiable at 0, so 0 is omitted from the option. Okay. See,
that's the thing.
Okay.
ma'am, my problem, ma'am, 8.2, ma'am. I think you're taking doubts randomly, ma'am. So,
Randomly?
ma'am,
No,
I'm
I'm
having some
going
doubt.
via the chat box. Tell which question? 8.2,
2, ma'am. Question number 8, 2. This modulus of sin x.
Okay, okay. Modulus of sin x, na? If then f is periodic with period pi. So what's your doubt in this question?
Ma'am, this second option is wrong. It's in continuous and differentiable. So, ma'am, how we will prove this without graph, ma'am, with using the definitions and all?
Just use the left hand derivative, right hand derivative thing, na? That will be enough. So,
Ma'am, this modulus, this is bothering me, ma'am, a little bit.
See.
Which
So
question is
left
this?
hand derivative is there.
8.2, question number 8.
Yeah, 8.2.
Bhakaran sir, it is question number 8, level 2.
See, differentiability won't be there whenever you have whenever the value of modulus will become 0, right? So simply just take at x is equals to 0. If you try to find out, then what is your left hand derivative? Left hand derivative will be this limit, right? Limit x going to 0, f of 0 minus f of 0 minus x upon x, right? So just try to find out what is the value. So this will become 0 minus f of minus x upon x, right? Now here f of x is given to be modulus of sin x. And you know, if your input is minus x in place of x, if I put minus of x, then minus sign will come outside of the sign, right? It will become minus 1. And because of modulus of thing, this will become positive, right?
Okay.
So this is nothing but limit h going to 0 minus of sine of h upon x, right? And you guys, I think, know that this limit is minus 1, sine x upon x, right? Limit x goes to 0, sine x upon x is equals to 1, right? But if you compute the right hand derivative, what will happen? You will get the positive one, because here minus will be there.
1.
I mean,
1.
Sine h upon x. So 1 will be. So that means not equals, that's why it's not differential. Now it's clear?
Yes.
Okay. Now let's go toward activity question 8.3, question number 5. What is this? 8.2? 8.3.
Ma'am, I still have doubt from activity 8.2.
Yeah. So post it in the chat box. Okay.
I have posted it.
No, wait. Don't. Roshni, you are asking, right?
Yes, ma'am.
Okay, let's go via activity only, right? Otherwise, so at which question you have doubt from 8.2?
Ma'am, question number 2, why option number 3 is not correct?
X square is differentiable at any real number a or not, limit h going to 0. So
Question number 2 of 8.2, why the option third is not correct?
because here option third is not correct because they only computed the right hand derivative, no? And based on the right hand derivative only, they are saying that it is differential.
No, there is
If you
no
want,
positive.
this is see what happened here.
You can share this. Maybe, ma'am, if you can share the question on the screen, it will be clear. Yes.
Okay. Yeah, I'll try to share.
Its limit is not 0. That's the only wrong thing which is there.
Let me see.
Question number third option, no? It should be
Yes, it will be 2A. Limit will be 2A.
Yeah.
This
But
is the
when
thing, na? So here A plus H.
it could be 0.
Yeah, if you cancel out this H with this H, then this 2A will be there, right? So this limit is computed wrongly. That's why this option. Although this is, yeah, correct. This is the only derivative we have to take. I mean, this is the only limit we have to check. But here this 2A will be there. Right. Thank you.
And question number 3, why option 4th is correct?
F is differentiable at x is equals to 1.5. So 1.5 is what? 1.5 is strictly greater than 0. So whenever it is strictly greater than 0, the function will behave like this function, floor function, right? And you guys are, if you are familiar with the graph of floor function, then you can easily say that the floor function is not differentiable only at integers, right? And 1.5 is not an integer. So that's why this option is true. Right?
Yes, ma'am.
Is that clear? Floor function is clear to everyone. Should I repeat?
No, ma'am, it's clear.
Floor function, ceiling function. I think we already discussed this in last session. In this session. Okay. So is there any doubt from activity 8.2?
Yes, ma'am. Question number 7, option number 3rd.
Let f of x is equals to x square for x rational and f of x is equals to 0 for x irrational, then it is differentiable. Let's see in this thing what is happening, that it's a function is behaving very I mean, what you can say, deflective kind of thing, right? Because you guys are already know that rationals are dense. Whenever there is 2 rational, there will be an irrational number in between them, right? So the function is actually fluctuating between the value x square and 0. That's why it is not differentiable.
Ma'am, it is showing correct. The option is correct. Option 3 is correct.
Option 7th question.
Yes, ma'am.
Then f is differentiable at x is equals to 0. Okay. Sorry, at x is equals to 0 is there now. So at x is equals to 0, x square also approaches to 0. So then it will become same thing.
If LHS, if fx is equals to x square, once it is giving for rational and then it is giving for irrational.
So whenever such kind of thing is happening, what happens? Function will actually take value 0, x square, 0, x square, very certain. I mean, if you draw the graph, it will become x is equals to 0 and this x square parabola. But what happens as x square also goes to 0, as x goes to 0, that's why this is differentiable. If they say that function is differentiable any other point at except 0, then this statement will be false. At 0 only it is true because of the thing, because x square is also going to 0 as x goes to 0. Because of that factor.
Slightly confusing. The nearest neighbor of 0 is it irrational or rational?
No, we can't say
Nearest
anything.
neighbor of 0 will be, we can't say, because it will be irrational. I mean, there are infinitely many irrational as well as infinitely many rational near 0.
So
you can't take any, you can't pick any of them because they are dense now. Between any two rational number, you can find irrational.
That's why my question is, so should I take it as a x square or should I take it as a 0?
No, take x square. Bhaskar sir, x equals to 0 is a rational number. It's not irrational.
Equal to 0 is okay. Nearby. When I say
nearby 0, nearby 0, you can't say anything.
If I take the left side 0 approach, I will take 0 minus h approaching.
But those things, h will also approach to 0 via real numbers. H could be irrational as well as rational. So you can't use the limit approach here. Because for limit, what happened? You have very, I mean, you don't have gaps between rational and irrational. That you can say, okay, I can pick all the rational numbers. That thing we can't. But
so
here, what is happening?
The function keeps
function is behaving very alternative. For example, see, if we can't draw the graph of this function what is mass, although we have to do.
Ma'am, we simply
But-
write down the function, ma'am. It will become clear to Bhaskaran sir
Huh.
also. Yeah, that f of x equals to x square when x is rational, and it is 0 when x is irrational. From there only we can say that x equal to 0 is rational. So we will take a function f of x equals to x square.
Right. So what you want to say that there are so many rationals and irrational near 0. So what you can do, you can take x to be irrational. I mean, you can take separate limit there. Suppose, actually in this kind of thing, sequential approach is very helpful. If someone from maths background, they can understand that what happened in sequence, we can pick a sequence which will take only rational values. And we can pick a sequence which will take only irrational value, and that goes to 0. Here, if you use sequential approach, then you can see.
That I will try. Okay, thank you.
But that is one part of real analysis, ma'am. It is not part of our course.
That doesn't matter.
That's why I don't want to explain that. But okay, you guys are little bit familiar with sequential things. So this is a particular question based on sequence. Then only we can.
So if we take sequence as rational, so it will be like a parabola, and if we take it as irrational, it would be like only on 0, constant at 0.
Right, correct. But as the point is given to be 0, that's why as we the point is given to be 0 and it's given to be x square parallel, particular parallel, right? So as we go towards 0 over rational points also, we are approaching 0, right? So that means the gaps between the function and the value become very less.
You take two sequences, both of them are rational, it will come to 0. If you take as a irrational
also, it will goes to 0. So that's 0. But actually, there is much more concept behind this. I mean, this is actually true because of rational, irrational. Somehow, if you union them, if you union irrational, rational number, then you will get the whole real number set. That's why you
Imagining,
can
ma'am,
take rational, irrational.
Just to imagine these things working, ma'am, it becomes very hard to imagine these things.
Right. So actually, they should not ask such kind of question here. But okay, fine.
That's the point I want.
Sir, sorry,
because it's actually.
Can you explain the second option, which is inverse of a differential function is differential, whether it is correct or not? Like
inverse of a differential function is differentiable. I don't think, because you can take x only, na. X simple, is differentiable, but it's inverse 1 by x.
Yeah. And you can also take sin
because
x.
Because 1 by x is neither.
Sin x is
sin
also
x
different.
Is also, but sin x का inverse थोड़ा मुश्किल हो जाता है. तो sin x inverse is bit.
अच्छा.
Sin x का inverse
cosec.
Hey, sin x inverse is not cosec x, it's sin inverse of x, right?
No.
Yeah,
it's actually sin inverse of x. That's cosec is actually like reciprocal.
Reciprocal. It's not inverse. Okay, fine. Let's move ahead. So 7th question is okay. 8th question. 8th question is just solved. 9th question. Question number 9. No doubts. Okay. Let's move toward activity 8.3. In this, see, I'll go question by question only. I'll give you hints if required. First question, which of the ones? Derivative, you just have to use chain rule. Okay. Second question is based on L'Hospital rule because there's 0 by 0 based on. Okay. Third question we already discussed. Fourth question, this simply based on derivative, and fifth question also something. Sixth question.
Ma'am, in previous exercise, question number 3, why option 1 is correct. Actually, I've posted the doubt in comment section, but
yeah. Question number what?
Question number 3.
Which option?
Ma'am, first option, f is differentiable at x equals to 0. Why it is correct, ma'am?
See, at 0, it's at 0, towards the right hand side, it's given by a floor function, right? So floor function and these two functions actually make a line there. At 0, what happened? It actually make a line. Line is near 0. because left of 0 is a ceiling function. So ceiling function will take one value upper, right? One value more than your value. So that's why it will become 0 there. And from the right hand side, it's a floor function. So that's why it will take a one value downward. So what happened? Near 0, you'll get a straight line. That's why this function is differentiable at x is equals to 0.
Okay.
When you work it out the graph, that will be.
Okay,
Haan,
thank you.
Sakshi, at which question you have done?
Yes, ma'am. Thank you, ma'am.
Ma'am.
Hello, ma'am. Hello, ma'am. Can you please take the practice assignment question?
Wait, we have been discussing activity
We are
questions.
going activity question. We
Maybe
have more
class will
sessions.
get over now.
We have more sessions. So
And just a one question with a one option doubt. Can you please take it? Please, ma'am.
Which question do you have?
Ma'am, in the question number 8.
Question number 8 of?
Practice assignment. Practice assignment 8.
Question number 8. Right?
Wait a second. Question number 6. Yes. I'm in question number 7, C option. And that in question number 7, GT, ma'am, third option. How is this correct? Can you please solve it? I was trying to solve it, but I'm unable to. Please.
GT minus G3 upon T minus 3 is equals to 9. So here first you have to compute the M and N value of this thing. GT is actually via the polynomial. Na? So here you have to compute the I'll give you the hint. Okay, third option you are saying, right? In third option, there's one plus sign is there. So plus sign means you have to compute the right hand limit, right?
Right hand limit.
And from the question number 6, you can find the value of M, right? So when you get the value of M, you will put here.
Yes, ma'am.
So you will use this expression, this 3 into T to the power M. For
so
computing
in place of GT, I'll use 3T to the power M.
Right. If you use that, I think that will be enough.
Okay, ma'am.
Ma'am, in this we were not discussing about continuity for an interval.
For an interval.
We have only
in this
discussed.
Question.
No, not in this question. My question is different. I'm asking that in this week we are always discussing continuity and differentiability at a point.
Right.
But in the graded assignment, they have asked in a question to check if it is differentiable for an interval.
To see what happened now. In that interval, there will be some certain points where continuity and differentiability will be obvious. For example, mod of x, right? Mod of x, if you move toward the right hand side, you will just find a line. So you know that line is all over continuous. So that part is gone. So that means there will be some portion of the interval where continuity and differentiability very obvious. That's the thing. You just have to look for some particular point. For example, in the floor function and ceiling function, we see that function is not differentiable or not continuous over the integers point, right? Over all other point, it's just behaving like a straight line, right? So at those points, it's already continuous. So some intuition you will find out, you will get certain points, and there will be much more specifically 1 or 2 points where you have to guess that what's actually happening. Is that fine?
Okay, but these functions are not quite trivial. They are some composition of exponential functions.
Okay. Composition. Okay.
You have a sample?
I can say the question, but I don't know
okay,
how.
Just
is it?
But yeah, because deadline is not over na, yet.
Yes.
Deadline is over.
No.
Okay,
so we will discuss it in the next session. Na, that
okay.
That will be fine. Don't worry, we'll discuss it in the next session. You can ask that.
But
now
will this type of questions be in the quiz too?
That thing I can't say. These type of question in graded assignment, then this type of question can be in quiz too. But I just practice it out. If it is much more difficult, okay. So what will be the deadline for this graded assignment?
Wednesday.
So after that we'll discuss. Na? There will be session on Friday and all. So if you are still struggling with such kind of question, we can take certain couple of examples.
Okay.
So let's now solve practice assignments only, because we don't have that much time. So first
Ma'am, but
question
I
is
have doubt
clear.
in activity, ma'am.
There will be much more sessions now. Yeah, we will go up to 10:30. Don't worry.
But we are continuing with activity, then we should solve activities first.
Yeah,
Okay,
it's better to go in order, I think. Like,
okay.
8.3, ma'am.
Activity 8.2 or 8.3?
8.3, ma'am. We were
There
on
is
8.3, question
there
number
is no
6.
continuity in our problems. We keep
Yes,
jumping here and there.
discontinuous.
So activity 8.3, what was telling,
Question
like
number 8,
first
ma'am.
2, 3. Question number 8. So in which of the following one can apply L'Hospital rule to evaluate the limit? You already know that whenever a 0 by 0 and infinity by infinity case is there, you can apply. So, so you can apply over the first thing, because it will be infinity by infinity case, right? Second thing also, because this will become 1, so 1 minus 1 will become 0, again 0.
No,
So I
first
think
option is not correct.
It's not correct.
x goes to infinity, this is infinity, and x goes to infinity.
Actually, this question was discussed in one of the TA session, and there he said that we have to check all the 4 conditions, like of
continuous differentiability and all those things that when you can apply.
So like it just satisfies 3 conditions and not the 4th one. That is why the first option was not correct.
Okay.
When you differentiate the denominator, then the limit won't be valid. So
Yeah, right.
I was asking about question number 5 of this activity. Yeah.
This question is clear then, na? I think you guys have already discussed.
Denominator, it will become 1. And how it's not valid?
1 upon 1 plus minus cos x. Oh, so here derivative is becoming 0. Now there is one condition that g dash of x is not equals to 0 when you apply L'Hospital rule. Right? Am I right? I'm
not getting it.
Sorry, repeat again. What did he say?
When we apply L'Hospital rule, there will be one condition which says that your derivative should not be equals to 0 if you have to apply that L'Hospital limit.
Correct.
Right?
But it
Continuity is there, differentiability is there, but if you differentiate this x plus sin x, then what happens? It will become 1 minus cos x.
Yeah.
No, 1 plus cos x.
But
1 plus cos x. It exists.
Next goes to 0. X goes to
1
infinity.
plus cos x. So it should be 0. The limit should exist.
No.
No, the denominator shouldn't be 0.
It's not 0.
No,
It's not
1 plus
zero,
cos 1 plus cos x means like when we put infinity, cos infinity,
it will be fluctuating. I mean, not continuous between
oscillating
1 and minus.
It is
Ma'am,
oscillating.
we should use
That's
the
why we
quotient
can
rule right here.
The range of cos x is 1 to minus 1, so it will oscillate.
Oscillating. That means derivative is not continuous, so that's why we can.
Derivative exists, but
it's not continuous. Although no, it will be continuous, but it's actually oscillating between.
Indeterminate. I mean, something is. It's not clear.
Okay, you guys have already discussed that. Don't waste our time. Which question? Question number 5 is there, right?
Yes.
This is also a particular case of element. Just put just take e to the power minus x to be x upon e to the power x. It will become infinity by infinity, right? X e to the power minus x is there. Just equate it to be x upon e to the power x, right? Then you can use L'Hospital rule to find out.
Oh, that works out to be 0. Yeah.
Getting right? Okay.
Question number 8, ma'am.
So
in question number 6, it is 2 statements are correct. First one is option C, and second one is, can you please explain?
At which question?
Question 6.
Down, ma'am, down. This one, ma'am.
Consider the following statement, this one.
Ma'am, one option C is correct and the other one is like which one?
Second
There are
option.
which are correct.
Oh, you have to
Then
compute
second
the derivative of log.
Second option will be
Second option is correct.
Second and fourth is correct.
Yeah.
Not fourth.
Second and
third.
fourth. He is right.
Yeah,
You will
have to
get
put plus in second and fourth. So
2x by x square, then you'll need to cancel it. So you'll get 2 by x.
Now, if you are
Just
having
write
doubt
out,
with
actually,
this, how this log e came over here, then you can write log 5 multiplied by log e. Log is basically 1. You can use the change of base. So you will get the answer this one. Ma'am, question number 8.
Yeah, I mean, it's a particular. Okay, question number 8. So f of x plus y is equals to f of x, f of y. So in this question, you have to find out f dash of 9, right? So
Yes.
this is actually a nice question. Here, first thing you have to guess what is the value of f of 0, right? So f of 0 is what? F of 0 you can find out via this condition, that f of 0 plus 0 is actually f of 0 into f of 0, this kind of thing, right? So the value of f of 0 can be either 1 or can be either 0, right? So then you have to guess the thing. Let's solve this.
Ma'am, it's been given that f of 9 plus 0 is equal to f of 9 into f of 0. We already know that.
F dash at 9 is already given. No, sorry, f of 9 is already given. I mean, what we have to do, we just have to use. So we have to find f dash of 9, right? So f dash of 9 is what? So its limit is going to 0.
Your screen is not visible.
Ma'am, your screen is not visible.
Good job. That's visible. Right?
Yes, ma'am.
So it's given that f of x plus y is equals to f of x, f of y for all x, y, and f of 9 is equals to 6, as well as f dash at 0 is equals to 4 is given to you, right? So just use these conditions there. So we know that f dash of 9 is what? So it is f of 9 plus h minus f of 9 upon h, right? This thing you can do. So if we do this, then limit h going to 0 will be there. Again, we can apply the property there, that x plus 1 property, right? Minus f of 9 upon h, right? So now this will become f of 9 will take common, and this is limit h going to 0, f of h minus this will become 1 upon h, right? Now this some certain, you can observe it that this can be written in this fashion also, limit h going to 0, f of 0 plus h minus f of 0 by h. If my f of 0 is equals to 1, then I can get that this is nothing but equals to f dash at 0, and then just via multiplication you can get your answer, right?
I got it.
Here you have got it, no? Yeah.
Yes, ma'am, got it.
Okay. Everyone is fine with that question, right?
Question 10 of activity.
Limit x going to 0 plus cot x sin 4x. Just replace cot by sin by cos and apply trigonometric formula. I mean, it's a computational question, right? Here they are asking you for finding out 0 plus, but I think you just have to go by the formulas. Is that fine? I mean, just remember the formulas of trigonometric function and how we can differentiate. So we just have to find out limit x going to 0 plus. This, I think, based on 10th question. Sorry. No.
Ma'am, we can apply L'Hopital rule, ma'am.
L'Hospital rule applies, right?
Yes, ma'am. We can write cot x as 1 by tan x. So sin 4x by tan x. So they both tend to 0. Then we apply L'Hospital rule and get the answer.
Yeah, just apply L'Hospital rule. That will be fine. Okay. Go to activity 8.4. So is there any doubt in 8.4?
Ma'am, this question number 2, ma'am, first and second option, ma'am, I'm having a little bit difficulty understanding the option.
Tangent to the parabola at vertex. At the vertex is x is equals to x. See, these are the parabola, right? So at vertex, they either have minimum value or maximum value. So that means curve, this type of thing will be there, right? So you have to observe which kind of parabola is. Just open it. I mean, if you are having trouble with this expression, just open it, differentiate it, and put the value of a vertex.
Okay.
That will be much easier as compared
Yes.
to observing the graph of parabola. Okay. Any other doubt?
Question
First,
7.
Second, 7. So use the linear approximation. This question, I think I already taken in last time. So in this question, what you have to do, fx is given to you, and we recently know that whenever we have to approximate the value at certain point, what we will do, we'll use linear approximation. So linear approximation is there. So that means so here f of x is given to be under the root of x, right? So here what you can do, you can find out f dash at particular point x, right? So there I think f of 4 is given that, or f dash of 4 is given. F dash at 4 is already given, right? So using this thing, you can say that f of x is actually equals to f of 4, and f of 4 you can calculate via the expression, like f of 4 plus f dash at 4 x minus 1. Now this is your linear approximation function. Now you have to approximate the value under the root of 4.4. That means you have to put x is equals to 4.4. Then only you will get here 4 under the root of 4.4 is actually equals to f of 4 plus f dash at 4, 4.4 minus 4. This will give you answer. Right?
2.1.
Any other doubt from this activity? No? From activity 8.4, no other doubts? Okay. Now let's go toward the practice.
Ma'am, in practice session, it would be better if you will hint from 1 to 10 means in sequence.
So,
yes, ma'am.
In first question, they say given graph and column B with the expression of the tangent at origin and boundary. Okay, so we have to plot the graph as well as tangent. Okay, so this is x into e to the power x graph is there. So, and it's tangent at 0, 0. So here you don't, you won't confuse via the tangent and the derivative, right? Derivative actually give you the slope of tangent. It won't give you the exact line, which will 8.8 is not there, right? 8.4 is the maximum. 8.3 question. Yeah, we'll go 8.3 after practice. So here you have to compute the tangent at 0, 0. So tangent at 0, 0 will be the line which passes through 0, 0, having the slope f dash at 0. So here what you have to do, you have to find out f dash and then put x is equals to 0, find f dash at 0, and then find out the tangent, right? So
Yes, ma'am.
when you find out the tangent, and then after that, I think the graph will be much easier to observe. Okay. All exponential graphs. Why the tangent only you can observe? Because these three lines are different. So this is y is equals to x. So this line is y is equals to x, right? And this is y is equals to 0. So this is y is equals to 0, and this is y is equals to minus 2. So first observe the tangent. What are the tangents? And then you can relate with the graph. Really easy.
Got it, ma'am.
Now this question is actually what I want to say, that whenever you have such kind of graph, now at this graph you observe that at point 0, at this point and this point, at all those points the tangents are actually parallel to x-axis. Whenever we have tangent parallel to x-axis, that means the slope will be 0, right? When so slope is 0, that means the derivative at that particular point is equals to 0. So that means at these 3 points the value of derivative will be same. Okay. Now here you observe that at point 0 we get some sort of corner type of thing, and whenever we have corner type of thing, we know that the derivative won't exist. Now this is a very smooth type of function. There is no corner, there is no anything else. But here also you can find out 2 points where the tangent will be parallel to your x-axis. That means the slope is 0, and this is a constant, right? So based on that information, you can say that there are at least 2 points on curve 1, which where the derivatives of the function corresponding to curve 1 are equal, right? So this option is true, because in this graph you observe there are 3 points actually where the tangent is parallel to x-axis, right?
Yes, ma'am.
This is an easy question. Now I'll go to this question. So this is actually what I want to say, that whenever you have such kind of question, whenever graph is there, then what you have to do, you have to approach a function from left or right, whatever sign is there, whatever limit you have to compute, and observe where your function is going, not particular value of that function. We know that the in case of limit, the value of function does not matter for us that much. In case of limit, in case of continuity, obviously it matters. In case of differentiability also it matters. But when we just talk about the limit, the value, particular value at that particular point does not. So here we have to just travel via our graph and figure it out where it's going. So this question is clear. Question number 3. Have you have any?
Yes, ma'am. It is clear.
Clear, right? Now go to question number 4. This is also some sort of what I want to say, that left-hand derivative, right-hand derivative you can use. That will be easy. You say, I mean, it's an easy question. Okay.
Yes, ma'am. We can move on.
Everyone is agreeing because I'm supposing that you guys can solve this question. If you won't solve it in quiz 2, then that will be problem for me. Everyone is comfortable with such kind of question now, right? We have discussed a lot of questions like this.
Yes, ma'am.
No, okay. Now, let f and g are two real value function defined as this thing. Linear function is the best approximation. Just find out the linear approximation. Fifth one is not that much difficult, right? Just exponential and polynomial. What can you say about this option number 2? Is that correct or not? Option number 2 of question number 5.
Ma'am, it is just random. I think so. It's right, maybe. Ma'am, it is just distributed.
There is a condition that limit extends to 0. Gx should not be equals to 0.
Yes. Right, correct. That's the thing you have to consider in this for saying that this option is not correct. Right. because
Yes,
if we
ma'am.
apply that, then in the denominator we get 0, right? And we
Oh,
don't
yeah,
want 0.
gx have a value, I'd say. Gx is equal to
Right,
x.
x. Look, the sixth one is we already told that left hand limit is equals to right hand limit is equals to value of function. From this, you can find out the value of n. Similar kind of thing you will do with g. You will
Ma'am,
find out the
in
value
this
of n.
limit t tends to 3 minus. Can you please?
Limit t tends to.
Ma'am, in question
This
number
one,
7,
this.
in 7, ma'am, the fourth part.
Hmm.
I've got the third one. But,
Fourth one, right? So 3 minus they are saying, right? So that means you have to approach from the left hand side, right? So over the left hand side is actually given via this rational function t cube minus 3 to the power 3 upon t minus 3, right? This is a
yes,
rational
ma'am.
function. And whenever you have to find out the limit of rational function, what you will do, you will try to cancel out the common factor between numerator as well as in denominator, right? So this is t cube minus 3 cube. So you can, use the formula this a minus b and bracket of a square plus ab plus b square. So if you use that formula, this t minus 3 and the numerator t minus 3 will get cancelled out. You will just be left with t square plus 3t plus 9, right? And there, that will be a polynomial, right? So then you can easily substitute the value of 3 and you will find it.
Yes,
I think this is not correct. Okay. Yeah. Question number 8 is again linear approximation thing. You already find the value of m and n, so function will be clear. Just use the formula of linear approximation, you can find. Okay. LF of 1. Right. Okay. Question number 9 says, this is the same question we just discussed in, right? Sarah sent that one question. Same with this question. We are given 2 points and the tangent is passing through that point, so we can find out f dash of minus 3. Question number 10. Just apply the chain rule to find out the derivative of composition function. You guys want me to solve these questions or the hint will be enough?
No, hint will be enough.
Fine. So I think we are done with practice assignment. Is there any other doubt in practice assignment?
I think activity questions are much harder than this practice assignments.
Okay, now let's go to 8.3. Which question someone asked? Question number 9. So question number 9, what does it say? Let f and g be two distinct functions from R to R, which of the following statements are true? First thing says, if f and g is differentiable, then both f and g are differentiable. So here you can take simple example, just take f to be x and g to be 1 upon x, right? Then the product of that function will be constant one function, right? Then to say x in place of f, take x, the linear function x, and in place of g, take 1 upon x. So if you multiply that two function, you will get a constant function. So that means the constant function is differentiable, but one of that function is not differentiable. That will contradict your first, right?
Why is that?
Now second, sorry, what?
Why saying that x is differentiable? 1 by x is also differentiable.
No, 1 by x is not continued at 0 now. So how could it be differentiable?
Continuous. It's differentiable.
But if a function is not continuous, then it can't be differentiable, right? That thing, there is a relation between differentiability and continuity,
Yes.
right?
Negative
Differentiability implies continuity, right? So if you negate this sentence, what does it mean?
Okay,
if a function is not continuous. Now assume that gx is not equals to 0 for all x belongs to real number. If f upon g is differentiable, then both f and g are differentiable. The same example works here, right? X and 1 upon x. Because again, g of x is not equals to 0 for all x belongs to. No. Distinct function for all. But here we have to take R to R function. But I think that will go. Okay. Now, if f is an even differentiable function, then f dash is an odd function. See, this option you can check via the chain rule, right? Just take, you guys are familiar with odd and even function, right? F of minus x is equals to f of x, then it will be an even function. And f of minus x is equals to minus of f of x, then it will be an odd function, right?
Yes, ma'am.
Right?
Yes, ma'am.
So what you can do, you can take a
Ma'am, you got disconnected, maybe.
So what you can do, you have to take f dash of minus x, right? So what is f dash of minus x? So f dash of minus x is same as d by dx of f of minus x, right? And this is same as this will become d by dx of f of minus x. If you use chain rule, then you have to deal with this kind of thing, right? First, you will do f composite g. Right. So here g of x is minus x. And what happened? This will become f dash of minus of x. And minus sign is there, but that won't tell us anything. Okay, fine, sorry. We have to use hypothesis first. That means if f is even, then f of minus x is equals to f of x, right? So if you differentiate both sides, what will happen? This will become f dash of minus x into d by dx of minus of x, and this is equals to f dash of x. So then this will implies that minus of f dash of minus x is equals to f dash of x. So that means f dash is odd, right? So in this manner, you can say that if f is even, then f dash will be odd. If f dash is f is odd, then your f dash will be even. Is that fine? This was the ninth 2 parts. Can you give any other example except of x and 1 upon x to contradict option number 1 and 2? Yeah, you can take f to be the constant function which is equals to 0. That means f of x is equals to 0 for all x belongs to real number. And take g to be any discontinuous function. I think that will work here also. Am I audible?
Let's say that again.
What I want to say that one thing I say that x and 1 upon x will work for that these two
right. that
options, right?
Sure,
But here I have a confusion that since f and g be two distinct functions from real number to real number, if I take gx to be 1 upon x, then you guys know that the domain of that function will be real number minus 0, right? So I think that example won't fit here exactly. That's why I want to ask you that do you have any other example in mind which contradict these two statements, 1 and 2?
Let's see that or not.
One example I have that one thing you can do, take f to be the constant 0 function, right? And take g to be any discontinuous function, any discontinuous. Then multiplication will be become constant function and division also.
Yeah, that's okay. That's true. That's of course a trivial.
That will be a trivial example. Other than that, I'm not sure.
X upon mod x.
But again, the domain left 0.0 now. No. Does it?
No, it's defined R. That's okay. He's not talking about the he's not talking about the range as a R. It's
correct.
It's a codomain. So that's okay. I mean, if you look at that, then x square is never a function at all.
Right. Fine.
Well, that's okay.
Okay. So I think we are done with all the doubts from activity as well as practice.
Ma'am, can you open ma'am tutorial 5 ma'am video?
Never said it.
Ma'am, this 6.50 ma'am timestamp ma'am. 6.50. 6 minutes 50 seconds.
6.5.
Yes, ma'am. Yes. over there. Ma'am, over here, ma'am, the way ma'am has explained over here that the function g of x, ma'am, this limit ma'am was explaining about this limit thing that it is approaching towards +1, and ma'am draw the line that it is approaching to +1 from this direction. How is that possible, ma'am? I mean, in complex analysis, this is possible, but when we are talking about real analysis, it can only approach towards this real axis, x-axis. So the direction ma'am has approached is wrong, ma'am. The way ma'am has approached to +1.
Limit
Are you
x going
getting
to
what?
1 plus?
Yes, ma'am.
Limit x going to 1 plus, no? So it's x square is given there. So what's problem with x square?
No. The way ma'am is approaching to approaching to 1 plus, ma'am.
Okay, let's see. This is no.
A little backward. Yes, ma'am. Here only, ma'am. Now, ma'am, will this draw that of this limit is approaching to 1 plus through this direction. This is what I'm not getting.
Limit approaching
1 plus.
See,
either the limit approaches towards from this direction or from the right direction. This x-axis only, no, ma'am.
So,
but here,
see, from from the left hand side of 1, if you approach, then your h of x is actually behaving like x plus 1, right?
Ma'am, I got that, ma'am. But ma'am, the way it is being approached towards 1, ma'am, that is my doubt, ma'am. It should be from this. The line should be parallel to x-axis.
Check the break in the graph, ma'am. To check the break in the graph, we have to go along with the graph itself, na, ma'am. Whether it is so, ma'am,
we take
it's correct,
input
ma'am.
from left and right, and
but
yeah, okay, fine now.
1 को अप्रोच तो ये एक्स एक्सिस के अलोंग ही करेंगे ना.
हाँ, वो एक्स एक्सिस के अलोंग ही हो रहा है, but we are moving along the graph.
That's why she draw an arrow there. It's actually based on.
Where is the confusion? No. Assume what is the value?
Actually, he's saying
1.0001. What will be the value?
No. My doubt was, ma'am said that as x tends to +1, the function is reducing. So in the limit, we basically approach towards any.
To visualize. Look, the easiest way to visualize is what is 1.1, 1.01, 1.001. All of them will become true.
Yes, Bhaskaran sir, what I'm saying over here is the way ma'am approached from the different direction towards +1. That type of approach is done in complex analysis. We approach from anywhere on the plane. We approach to the that particular point of our interest.
Now I'm getting what you are confused. Okay, fine. So you go via x because you know the higher multivariable calculus. We do that stuff, right? Whenever we have x and y axis, then we can move toward complex analysis.
Any direction. That is what I'm saying.
Any direction will work, but here it should. Okay, fine. That's okay. I mean, when we talk, then such kind of thing happen. Although that's also not truly, I mean, very wrong. It's okay, fine.
Okay. Thank you, ma'am.
Okay.
Thank you.
So I think with this we can wrap.
Good night, sir.
Good night.
Yeah. Good night.
Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you for joining.
Thank you, ma'am.
Thank you and good night.
Good night, everyone.
Good night.
Thank you, ma'am.
Thank you.
Ma'am, can you send PDF? Hello, ma'am.